I'm Tom McKarns from Ecophysics, and this is section B4, NOx testing, control, and sensors. I'm going to be talking about tips for better NOx analyzer routine maintenance, basically. Kevin Doherty is here from Fuel Tech. He's going to be talking about NOx reduction for EPA Good Neighbor Rule. Lauren Novacek is here from Aeronox, talking about Aeronox's SCR NOx reduction system. And Keith Brand is from Thornton, and he's talking about common pump bearing problems and how to solve them. So we'll go ahead and get started. First of all, I guess I have a question for everybody. Is anyone here using a NOx analyzer? Anyone making some measurements, stack emissions? So that's what we're going to be talking about here. Our particular analyzer from Ecophysics is called the NCLD. It's a chemiluminescence instrument and used routinely for stack measurements, but also for research measurements of NOx. So today's talk is geared more toward stack emissions and common problems that you'll see with NOx analyzers. So our instruments laid out in a modular design, as are most instruments. We have a ozone generator here for the ozone generation of the chemiluminescence reaction. There's a power supply, a perma-pure dryer for drying the ambient air that we are going to use to make ozone. This is our vacuum pump, and this is the reaction chamber and detector. And then back here is the hot box, and that's where we do the destruction of the ozone. So we're creating ozone for the reaction. We need to destroy the ozone rather than just dump ozone into the atmosphere. The ozone would also chew up the vacuum pump, so it's another good reason to take care of the ozone. All our instruments have a preventative maintenance schedule, so when you buy an instrument, you're going to know at what intervals you need to do your routine maintenance. I won't go into all the different areas here, but basically everything that needs to be checked or replaced on a certain time schedule is going to be mentioned here, and whether it's a replacement or whether it's just checking the device to make sure it's all working correctly. Inside the analyzer, first of all, the diagnostics. So the screen on the front of our analyzer is going to help you keep track of the reaction chamber pressure, the dew point, and the bypass flow. And we have individual temperature readings from any temperature device that's inside the analyzer. We also have pressure readings. Just in the last year, we've added a dew point sensor. So you can see that down here, and that is the dew point of the permeation dryer, and then the dew point of the air that's being used to purge the detector. The detector is cooled detector, so we want to make sure we keep that air dry in there. So we do have, as you saw in the previous slide, a maintenance schedule for when you should replace things, but this is also an additional safety so that if you do have something go wrong with your permeation dryer, you'll find out about it by an error message in the instrument. There are no errors on the screen right now, but if there were, they would show up in this yellow color. That's the color for any kind of error, and it will give you an error code and basically tell you what the problem is and what you should do about it. So a chemiluminescence analyzer is laid out pretty similarly for the different manufacturers. In this case down here, you can see we have a sample gas inlet. There's a particulate filter that you would use, and then there's a sample gas restrictor. So we want to control the flow of our sample, and we want to control the pressure of the sample as it enters the analyzer. In the case for NOx measurements with a chemiluminescence measurement, you're also going to have a converter. And then there's a valve, a switching valve here to switch back and forth from NO to NOx. Most of our customers are just using it in the NOx mode, but you do have the capability with this solenoid. Then you have the reaction chamber. So this is where the sample meets up with the ozone. So the ozone is pulled in from that's actually the exhaust, but here's where the ambient air is pulled in through a filter again, goes through the permeation dryer, and then it goes into the ozone generator, where we generate ozone at concentrations up to about 0.4% concentrations. That concentration is high enough that we can then have our reaction, the reaction chamber between ozone and nitric oxide. That reaction gives off light, and then we use a photomultiplier to detect that light and to quantify it. On the back of our analyzer, you're going to see a couple large fans for cooling. So we pull the sample, we pull the drying or cooling air through the front, pull it past all the components, and then it goes out the back. So if you have anything sitting on top of your analyzer or below it, it's not going to affect the cooling. So the cooling goes in the front, out the back. Down at the bottom, you have an exhaust line. You have the sample line where your sample actually comes in. And then up in this corner, depending on the analyzer, we have some simpler analyzers that don't have any connectors on the back as far as USBs. Those are for environments at large power plants or refineries where you may have security issues and you don't want to have any chance for somebody entering a virus through a USB. But our other instruments always have USB fittings here for external keyboard, external mouse, external display, whatever you want to do. We also have on many of the analyzers an HDMI port on the back for connecting an external display. The vacuum pump is kind of the heart of the instrument. It's what's pulling our sample through the analyzer. It helps to maintain the flow and the pressure. So it's important to take good care of the vacuum pump. Taking good care of it means once a year maintenance. So it will run 24/7, 365 days a year without any maintenance at all. But when you get to 1 year, then you should start thinking about when you're going to do your vacuum pump maintenance. Many of our customers do their own maintenance on their vacuum pumps, but you can also send the instrument in to us to do the routine maintenance. Basically, there are some head covers on both sides of the pump. You can remove those, and then you can replace the membranes and valves inside. To tell whether the vacuum pump is reading correctly, it requires a high-quality digital vacuum gauge where we can connect that and then detect the vacuum created by the vacuum pump after we do the service. Inside the pump, there are some heads which are made of aluminum. Those heads, as you can see in this photo right here, can get deposits on them. The deposits come from whatever's in your sample stream, so depending on the source or the kind of fuel that you're using, you may have different deposits that end up forming in the pump. Those can usually be cleaned out very easily if you do it on a once-a-year basis. If you let your routine maintenance go too long, then you're going to have more deposits to work on. So after you take the head covers off the pump, this is what you'll see inside. So these are small rubber membranes, little flapper valves, and the positioning is, it's always good to take a picture. We have manuals which are available for all of our instruments with good photographs inside so that when you take apart your pump, you'll know exactly how to put it back together again. That's the goal. So in addition to the vacuum pump, you also have restrictors inside the instrument. So remember we showed that first graphic showing the flow through the instrument. we control the flow through restrictions. So we have 4 restrictors. We have 2 ozone restrictors and we have 2 sample restrictors. And that's a fitting. It's a swage lock fitting. There's a disc, a metal disc with a very small precision hole drilled in the center of it. And that's what we use to control the pressure and the flow through the instrument. So those can be taken off, put in a ultrasonic bath, and usually about 20 minutes is sufficient to clean out any deposits. You may want to check your sample lines leading up to the reaction chamber, so these lines, just to make sure that there's no deposits in those. In this case, we've just taken the cover off the reaction chamber. This is a heating pad. We hold our reaction chamber at 55 degrees C for a good temperature stability. And then we have a detector that's cooled to 5 degrees C, and the detection is done at a lower temperature. So here you can see we've pulled out the reaction chamber. There's actually 2 chambers in this instrument. Some of our instruments have just 1 reaction chamber, and there are a couple of small bolts that we remove. And then we can take apart the reaction chamber, clean it if necessary. If you need to replace a part, there's replacement parts available to replace anything in there that you want to replace. All right. This is a little bit closer look at the reaction chamber. You can see the wires going in at the bottom for the temperature control. And then at the top, there's a rubber membrane which can be replaced. That gives you even more information showing the ozone restrictors. So you just need a simple wrench to take those fittings off, put those in an ultrasonic bath, and clean those. After we do the routine maintenance, we have a certain flow rate that we are looking to achieve, and that's what the factory value is when the instrument left the factory. And so again, we use a precision digital flow meter for this purpose. The one we use is from Sierra. It's called the Ready Compact, and that's actually probably around a $900 digital flow meter. Once we've finished the routine maintenance, we perform a calibration on every instrument. What we're looking for is whether or not the instrument is reading the proper number of counts per second. So again, the instrument, the technique is called chemiluminescence. It's a chemical reaction that gives off light. So the amount of light that we see is going to be proportional to the amount of nitric oxide that we're measuring. So we have a certain target counts per second that we expect to see for our sample concentration. And so this is something you can check when you do your calibrations to make sure that that NOx number is reading where it should read. If it's not, that's probably an indication that one of the restrictors is still not clean enough. So you probably have to go back and clean it. Secondarily, if you look at the reaction chamber pressure, so here it says reactor, it says 18.3. We want to look at the reaction chamber pressure. If we have cleaned the restrictors properly, it should come back to this reaction chamber pressure every time. And so for each instrument that leaves the factory, we have a test report that shows what all the values were when the instrument was new. And our goal is to make sure when we do the routine maintenance that we clean everything so that everything's reading back to the factory values when it was manufactured. The temperatures are set by the instrument. There's nothing we do during the routine maintenance that would change the temperatures. You have temperature sensors and you have heaters. And those are like a small stick that goes into a slot inside the instrument. If they're not pushed in all the way, it could be that your temperatures don't reach the target temperature. So during your routine maintenance and your checks afterwards, you want to make sure that all your temperature values are showing up where they should be. Behind the front panel of the analyzer, we have a fan filter and dry air filters. So those dry air filters consist of 3 different components. There's a component that removes the organic materials. There's a filter for the inorganic materials that might be in the air surrounding the instrument. And then we also have a NOx cartridge, that's the purple potassium permanganate material, and that removes any NOx. So we have an add-in air feature in our instruments. In most of the applications, there is some oxygen available. The oxygen is not needed for the chemical reaction, but it's needed for the performance of the converter. So if you're measuring from a sample source and there's almost no oxygen in there, we do have a feature built into the instrument that adds in a little bit of ambient oxygen as well. And so we need to scrub the ambient air of any NOx because we don't want to add to the sample NOx value. But those are cartridges which are replaced, and they just pop out and you replace all 3 cartridges at the same time. The instrument has an NO2 converter, and it's replaced about once per year during the routine maintenance. This photo, you can see a screwdriver there beside it. The converters are usually about as long as my finger, a little bit bigger around than that. There's a couple 1/8 inch swage lock fittings where that connects inside the analyzer. So if you're using your instrument routinely, you're going to need to replace your converter about once a year. If the converter is exhausted, it's been used up, you will not read NO2 correctly, nor will you read NOx correctly, because we have to convert the NO2 to NO so that we can measure it. So you need to make sure that your NOx converter has been replaced, especially if you're going to have a RADA, an outside group, come in and do a RADA on your instruments. You want to make sure that you have a brand new converter in there so you're reading all of your NOx correctly. The instrument keeps track of the operating hours. That's the total number of hours that the analyzer's been run. And we also have a countdown timer for the pump and for the converter. So when the instrument's brand new, we type in a value of 10,000 hours for the pump, 8,000 hours for the converter, and then that's a countdown timer. So every hour that the instrument's on, the countdown comes down. So when those numbers get down to 0, you'll get an explanation on your screen that pump maintenance is due or that your converter cartridge maintenance is due. So kind of like in your cars, and cars these days have a countdown on your odometer and tells you when it's time to change your oil, for example. That concludes my talk about the routine maintenance for the NOx analyzers. Our company is called Ecophysics. We're located in Ann Arbor, Michigan. We represent the products of Ecophysics of Switzerland. So all the chemiluminescence NOx analyzers are made in Switzerland. We've been in business for 28 years. And in addition to the NOx analyzers that we represent, we also represent a company called ETG from Italy, and they are making a variety of detection technique analyzers, including FTIR, tunable diode lasers, photoacoustic measurements, and some NUV and NDIR instruments as well. Are there any questions?
On how many NOx analyzers you have in the U.S., you think?
Oh, I have not gone through to check over 28 years. It's in the hundreds. I don't know whether we're in the thousands, but certainly in the hundreds of units out there.
Yep. So spare parts coming from, I think, come from Switzerland or?
Correct. Yep. We maintain an inventory here.
Okay.
So in 28 years of business, we have a pretty good idea of which parts are going to be needed routinely. And so we are constantly ordering parts from the manufacturer to replenish orders we get. Once in a while, we'll get a really large order for a certain part and will be depleted. Usually within a couple weeks, that's replaced. But we do always maintain a pretty high inventory of the most commonly used parts here. So that when we have a customer that gives us a call, or if an instrument comes in for routine maintenance, that we have the parts ready and that we can turn the instrument around, very quickly within a couple days. The policy of the Swiss is that after they finish manufacturing an instrument, they guarantee parts for an additional 10 years. So we still have instruments we're maintaining that were discontinued over 10 years ago, but we still have parts. We tell our customers we can't guarantee how long we'll have parts, but some of the parts, like the converters, some of the pump parts, those parts have been around for the beginning, so 30 years. And so they are still in use today. But we have several customers that have instruments that are 18 to 20 years old and still maintaining those now. And they're using instruments that were discontinued maybe 12 or 13 years ago. Any other questions? All right, so I'll turn it over to Kevin Doherty. And let's see, I guess I need to shut down mine.